Foldable solar panels were invented in the 1990s for American soldiers in the field. They use them to recharge electronic devices. The panels have environmental and tactical advantages, conserving both electricity and physical energy. Today, foldable solar panels are not just for the military. These lightweight panels can be folded up and tucked into a backpack, allowing anyone to escape to the wilderness but stay plugged in. Production starts with a roll of thin plastic film. It's the same material used to make flat-screen TVs. A worker loads it into machines that distribute thin layers of aluminum and silicon onto it. The aluminum acts as an electrical contact. The silicon produces electricity when exposed to the sun's rays. Next, lasers carve vertical and horizontal lines into the film. These lines define the solar cells. An automated squeegee applies black ink through a screen and into the lines. The ink will act as an electrical insulator. It also makes it possible to cut through the film without damaging it. UV light cures the insulator ink. An employee pours a generous amount of metallic silver ink onto a pattern. A squeegee forces the ink through to the solar film. This creates a conductive grid on the film. A camera magnifies the grid for inspection. The solar film travels through a chamber where heat cures the silver ink. A laser now connects the solar cells, linking the bottom aluminum layer of one cell to the top silicon layer of the next. The laser ties them together, similar to how a soldering tool would. This establishes electrical connections and increases the voltage significantly. A different camera magnifies the connections to check the alignment. Now, a worker loads the solar film into a machine. It deposits a transparent oxide onto the film that will increase conductivity. These solar cells are now fully functional. The next machine tests each one. It also applies a conductive foil tape at certain points. Another machine rolls a clear sheet of plastic onto the solar cells. The plastic adheres to the cells, waterproofing and encapsulating them. A die press cuts out solar panels along the black insulator lines. The press uses computerized cameras for accurate cuts. A robot transfers each panel to the next station using suctioning heads. A computerized camera scrutinizes the panels for defects. After more testing, they deposit the panels on a piece of fabric. A laser cuts the fabric around the panels. Heated rollers bond the plastic panels to the fabric. Now, an employee burns through clear plastic film to reach the conductive foil. He solders wire to the foil at these points to connect the positive and negative leads. The wire is flexible and will bend with the fabric when it's folded. A seamstress now stitches strips of fabric over the wires, enclosing them in a protective pocket. Another member of the team solders a connector to a circuit board that's been attached to protruding wires. He squeezes silicone into a plastic cover and places it on the assembly. The silicone solidifies around the components to protect them from water damage. Finally, he rivets the cover to the fabric. This foldable solar charger is ready to be bundled up and placed in a backpack. It can power a laptop or a smartphone, keeping the user connected anywhere in the world.